pi over, oh, come on, pi over 2 and 3 pi over 2. Bless you. What were the steps, guys, in order to solve and get sine all by itself? Peyton. What'd you have to do to solve this equation here, number 2? Perfect. What else did you do? Okay. What did you do next? Okay. Where did you find that out to be?
Pi over 3 and 2 pi over 3.
Pi over 3 and 2 pi over 3? Okay. Where's pi over 3 located? Okay. So the square root of 3 over 2 is negative. So you're going to figure out where your pi over 3 for reference is correct. That's spot on. However, we need to make sure that it's negative. So where is sine? What quadrant is sine negative? You see it there? Tangent and cosine are the only two functions that are positive in the third and fourth quadrant, which means that sine is going to be negative. So whereas this is correct as a reference angle, go ahead and put this reference angle now in the third and fourth quadrant. So what would that look like now, Peyton? So take the denominator and add 1 to it. What do you get? That puts pi over 3, which is the right answer, into the third quadrant, which now fits its sign. So now you're getting negative square root of 3 over 2, which is exactly what you want. Now let's go ahead and put pi over 3 in the fourth quadrant. So now you take the denominator, double it, and then subtract 1, and what do you get? There you go. I guess I shouldn't box that pi over 3. It's kind of your reference there, okay? All right, so this goes on. These are some nice steps, guys. This little thing right here is great to help you out, just to go through steps. So it says strategies for solving trig equations. First thing is get the trig function by itself to the first power. We've been doing that all morning. For the past 40 minutes, that's all you've been doing is solving trig functions and getting it to the first power. If it's squared, you guys end up taking the square root. You might have to use GCF, so there's factoring involved, difference of squares, Pythagorean identities, we'll talk about that later, or just straight up factoring, which means we might be using the box method or whatever you use to factor trinomials. You might have to take the square root. Don't forget, if you take the square root, it's plus or minus. Then it goes on to say if the trig function is cosecant, secant, or cotangent, inverse functions, rewrite the terms in sine x, cosine x, and tangents. Remember, guys, cosecant is 1 over sine, secant's 1 over cosine, cotangent is 1 over tangent. So what you'll end up having to do is, if you end up with the answer being the cosecant of x is equal to 2 over 1, I need that to turn into sine. Well, you just flip it. So now you say the sine is equal to 1 over 2. That's what you're doing for inverse trig functions. And now I'm going to go ahead and put that over here. Flip. Fraction is what that means. And it says use the unit circle to find angles that work for the given interval. We've been using the square root trick or the hand trick, whichever one it is you do. And then read the directions to see if the answer should be in radians or degrees. 3 steps, each 1 and 3 have some multiple sub-steps, okay? So looking at the next one. See what these look like. So it looks like our answers are going to have to be in radians. So we have cosine squared is equal to cosine. What do we do to get cosine all by itself? Square root. If you take the square root, you're going to end up with the square root of cosine. Yeah. Subtract. She's talking about quadratic because you see squared, which means that you need to get it equal to 0. Subtraction is right. Okay. Gotcha. Okay. If you have, and the only reason why we had to subtract there, Mackenzie tells us to subtract, is because we have cosine squared and we have regular cosine. Hey guys, if we had cosine squared and that was it, no other cosine anywhere in the equation, then you'd square roots. We've done that already. We did that this morning already. But since there is two cosine functions, one is squared and the other one's to the first power, you got to set it equal to 0 and solve. So what do we do here to solve this, guys? Victoria, do you have any ideas? Factor. We are going to factor. She's exactly right. If it's a squared function, guys, and you have more than one term, you're going to have to factor. She's right. Can you give me more specific? What factoring are you going to have to do here? How many terms are there, guys? 2. Good. Do both terms have something in common? What is it? So we're going to factor out cosine. GCF. Greatest common factor. We're going to take a GCF out. Be very careful. Don't fall into this. It's an old trick that people fall into, and that is this. When you factor out a common factor, and one of those terms is the factor itself. For example, one of our greatest common factor is cosine theta. Look at our second term. What is our second term? Cosine theta. That is what it is, right? When you factor it out, though, I see a lot of students just remove it. They take it away, and all of a sudden they're left with is cosine all by itself. Guys, if you have two terms and you factor out a GCF, what's inside your parentheses is still two terms. So you see that 1 there? Because we divided cosine theta by cosine theta, that's why you get 1. When you factor something out, guys, you don't lose terms. You're just reducing them. You're making them smaller. Okay? So that's what we did here. We factor out a cosine, and we divided both terms by cosine. Does anybody remember what we do here now? We have two terms that are being multiplied together. Did y'all see that? Granted, one term has something in it. But what is that common rule? If I want 0, I multiply two numbers together. What has to be true about one of those two numbers in order for their product to be 0? One has to be negative. One has to be not negative, but what's 17 times 0? 0. What's 100 times 0? 0. What has to be true about one of the terms? 0. So this is the part, guys, where you go back. It says algebra 1. Take this, set it equal to 0. Take this, set it equal to 0. Where's cosine equal to 0? Where's x equal to 0? Where's x equal to 0 on the unit circle? Bless you. That takes care of one. Let's do the other one. Is cosine by itself? No. Now it is. Where's cosine equal to 1? 0. Cosine at pi is negative 1. All comes down to here is where it's at. Okay.
Isn't it the same as 2 pi?
Be careful. If its cosine is positive, yes, it is the same. But if you look at the interval of the answer, look up at the instructions. It says 0 and include it, but 2 pi, but do not include it. Do you see that? So be careful with the answer. You won't put 2 pi as your answer. You'll put 0. All right, on number 2. Again, going back to algebra. What would we do here, guys? How many terms? 2 terms. Do both terms have something in common? Yes, what is it? Do the same thing we did before. All right. Secant of theta. Secant is 1 over what, guys? Secant is 1 over cosine. So we have to flip this. So what ends up happening is secant is equal to 0. Okay? So we end up having something like, where is secant equal to 0? Try and get a different color. And so we have to flip this, all right? And so we have this little 0 over 1. We flip it, and then what happens? What's wrong with this? 0 on the denominator. What does that tell us? Undefined. So guess what? There's no solution for that particular side of it. That one's gone. That doesn't exist. In other words, secant, there is no angle that secant equals 0 at. All right? So let's go ahead and look at cosecant. And so cosecant is the inverse, or 1 over what, guys? 1 over sine. And so we see sine of theta is equal to 1 over 1, because I flipped it. Better yet, 1. Where's sine equal to 1? Anywhere else? Be careful. What's that 3 pi over 2? Y is equal to what? Negative 1. So no, just pi over 2 is going to be the only answer there. So in other words, pi over 2 is the only degree here that will work to where these will cancel out each other. All right?
Wait,
Yes, sir?
why did you put secant, why did you put cosecant in the parentheses? Is it because it's the only one? You didn't combine it?
Oh, yeah, because cosecant in the parentheses, because when you take secant out of both of those, secant's in front of the parentheses, and you take each term and divide it by secant, you'll get cosecant's left in the first term, and then secant divided by secant ends up being 1. And so that's why it's cosecant minus 1. There. I'll let you do the next one, guys. The next one we've already done this morning. Yes, ma'am. Teaching square root. What's the square root? So we go through, we'll say let, bless you. We're going to let this happen because we can make this type of substitution, guys. And now we're dealing with something that's familiar. Now we see 2x squared minus 3x plus 1 equals 0. Oh, yeah, we've seen this before. We're not proud of it or happy that we have to do it, but we've seen it before. This is a little bit more familiar. So at this point, you can do box method or whatever it is you do. When I factor these guys, this is my process. I go ahead and write out two sets of parentheses. I put both first terms as the 2x. I look at the very last sign and say, since it's positive, that means both of the last terms are going to be the same sign. Because a positive times a positive is a positive, a negative times a negative is a positive. So they're both going to be the same sign. They're going to both be negative. And this is what you used to have to do. And we still have to do this. You can't get away from this, unfortunately. You have to multiply this times this. You get 2. And you say, what two numbers do I go ahead? The signs are going to be the same. Do I multiply and get 2, but then I combine and get negative 3? So minus 2, minus 1. And I do one last thing. This is an alternative to the box method, and that is this. Can I reduce any of these parentheses? What's in parentheses? Can I reduce anything? Yes, what I see here is there's a 2 there and a 2 there. That can reduce. 2, my final factor. X minus 1 times 2x minus 1. Those are my two factors of this. So we factored it. There's nothing else we can do factoring wise. That's done. Now we just plug sign back in and set each one of those equal to 0. So I say sine theta minus 1 equals 0. 2 sine theta minus 1 equals 0. So where does sine equal 1? Where does sine equal 1/2? Where does sine equal 1? Where does y equal to 1? Good. Where does sine equal positive 1/2? Sine number of fingers on bottom. Good. Except are they in radians? Are these answers still in radians? Is that right? Okay. So pi over 6 is exactly right. It's got to be positive. So what quadrants are we in? First and seconds. So basically, I say it's the hardest part because, guys, we're combining everything we've done all the way up until now. We have found solutions to a trig function to solve. We've had to break up and set them each one equal to 0. And then we also had to factor. So every single thing we've talked about is all involved in that one problem right there. And yes, it'll be on the quiz, and yes, it'll be on the test. The other way of doing it, guys, is just leave sign there and work with it. I've seen students do that too. I've seen more students do that just because they're lazy. They don't want to do the whole one extra step of substituting x in for sine. I find substituting it in is easier just because you can see something that's familiar. Now after you do it for 2 or 3 weeks and start feeling comfortable with it, maybe leave it in and see what happens. When you start writing this right here, guys, I'll tell you this. If you don't substitute x in and you start writing that, it gets really confusing. There is a lot of numbers and letters involved in that equation, and you can get lost in it pretty easily. That's why I think substituting x is probably a good trick to have. All right? Okay. Let's move on. All right, number 5, solving. What do we do, guys, here? Just regular solving, so there's no factoring in anything. What do we do here to solve? And then what? By 4.
Why is it 2?
Why is it 2? Because you have 1 root 3 minus 3 root 3's. So it's negative 2 root 3's. Does that reduce any, guys? Can 2 go into 4? How many times? Twice. Hey, good thing that happened that way, because now we have something that looks familiar. So, where is sine negative root 3 over 2? In degrees. 60 is a reference angle. That's good. I'll write it off to the side. Where is 60? Well, what quadrants is sine going to be negative in? Third and fourth. So what is 60 degrees in the third, and what's 60 degrees in the fourth? 240 and 300. Good job. All right. Number 6. What do we do? Plus 3. Remember, you add or subtract first, and you multiply or divide last, right? In that order. What's last? Divide by 5. Cosecant, which is the inverse of what, guys? 1 over? Flip it over. So cosecant of what angle equals 1, or sine of what angle equals 1? Pi over 2. One and done on that one.
Why is it pi over 2?
Oh, is it in degrees? That's a good question. Nope. That's right. We got points off on that one. Alright, number 7. Trying to get to these, which are just something you haven't seen before. Here we go. What do we do for number 7 first, guys? Subtract 1. And then what? Is it stinky? It smells like stinky feet. It smells like shoes. Some people need. Okay. I need to redo mine. I'm refreshing up my air fresheners. Is that what it is? Maybe. Okay. I'll work on that. I don't want a stinky room. All right. So what's last here? So for this, guys, when you're asked to solve this stuff, I would highly recommend just leaving it in this form because it's easier to see. Because what's about to happen too is going to be it's cotangent. Well, cotangent is 1 over what? 1 over tan. So in order to solve this, you have to flip the fraction, right? Leaving it still negative. We don't have to change the sign, we just have to flip the fraction, that's all. So it's still negative. So what degrees? The tangent of what degrees is going to give you negative square root of 3 over 1. Tanner?
The degree of it
Yes, sir.
would be 30.
Close. Keep going.
Is it one more for 60, right? 40.
Nope, 2 more up.
Right.
You passed it. We need 3 over 1. You all agree? 3 over 1? That is 60. It needs to be negative. So where is tangent negative, guys? What quadrants? I'm got all answers. 2 and 4, 1 and 3, 2nd and 4. Let's think. Let's come over here. It needs to be negative. All are positive in the first. Sine's the only one that's positive in the second, so tangent would be there. Tangent's only positive in the third, so that's not it. Why'd I box it? And then finally, cosine's the only one in the fourth, so it's going to be second and fourth. So let's put 60 degrees in the second quadrant. What is that? 120. Finish up with 60 degrees in the fourth quadrant.
Wait, why would it be first of all?
All trig functions are positive. I know that these sometimes throws off sometimes because you're like, okay, I need to find where it's negative. So you just look for tangent, and some people say, oh yeah, it's right there. You got to remember, these letters tells you where those trig functions are only positive. So if it's negative, you're looking where it's not. All right, I'll let you do number 8 with a partner. Or 2, or 3, or 4 people. However it needs. Or the whole class.
I don't know. I'll let you know.
Did you get... Did you get that when you factored? Let's cross the big speed bump is the big hill we got to climb is the factoring part. Did you get that when you factored? Perfect. Okay, so at this point, we go back to putting cosine back in. And then from here, it's just what we've done already. So it's, the first thing is going to go, can you factor correctly? Can you get that factoring right? If that's the case, then you go back and plug cosine in for x, and then now you solve the rest of the way. And I have a strong feeling if you get to here, this part you guys will get. I feel a lot more confident you guys will get this than getting that. It's just my experience with juniors and seniors.
I was the other way around. No, I did the factoring fine. I'm just doing for the finding for like the degrees.
Oh, gotcha. Okay.
We have a quiz.
So you did end up with this, right?
Yeah, I got a negative one.
You got -1? Or -1/2? Okay. But you did end up with 2x minus 1. So we don't see it all. Let's solve it.
Do you have
Yes, I do.